curved mirrors, and we're going to start by looking at the concave mirror. We know it's a concave mirror because it resembles what a cave would look like. Now, for this demonstration, and the way that you would view this if you were using your light boxes in the classroom, would be using the block with 3 slits in it, so that we're going to get 3 light beams coming out of it, and these light beams are equal distances apart. Now, our middle beam, we're going to be aiming it at our vertex, which is basically the middle part of our mirror for these purposes. And when we look at individual rays, we're going to be looking at the reflection that they give off. Now, our middle ray is going to be hitting it at right angles, so it's basically a flat surface. If we could imagine this surface being flat, the light is going to be reflected directly back along the same line, so we don't need to draw that. What we do need to draw is how this ray and this ray are going to be reflected, and they're going to be in these angles. That's how they're going to bounce off. And it's going to look like this. Now we know that this is how it's going to be reflected because from our last lesson when we looked at angle of incidence and angle of reflection, and that's how we know that our ray is going to be reflected that way, based on the law of reflection. Now there's an important thing to notice about this shape that we're getting, and that is based on the 3 rays and where they intercept. Now the point at interception, which is this point where the 3 of them cross over, we're going to call that our focal point. Now our focal point is in exactly that. It's where it's focusing at. Now the focal point is going to be consistent no matter where I shine these rays. All of these 3 in a concave mirror are going to intercept at some point. The other important thing to notice is that we can measure the distance between our mirror and where it intercepts to find out its focal length. Now the focal length is the distance between where each of the points intercept our focal point and the surface of our mirror. That is going to be our focal length. Now the focal length is going to change dependent on the curvature of our mirror. So if we make our mirror less curved, so we flatten it out, our surface that our light is reflecting off is a lot flatter, which means that the angle that our light is reflecting off is going to be straighter. It's going to be more direct back at it. If we look at this from a changed perspective with a different lens, our light now intercepts further away. Our focal point is now here, and our focal length going from this distance has now almost doubled in size, or more than doubled in size. So by reducing the angle of curvature, we're actually increasing the focal point. And the same applies if we were to increase our focal curvature. Our focal point would become shorter. Okay, so what happens when we look at a different kind of mirror, and we're going to look at a convex mirror, so the opposite of a concave. This time we're no longer facing inside the cave, we're looking at the outside, and our light's going to reflect on a different angle. Just extend these light rays. Using the same principle of reflection, our light is going to reflect off on a different angle. It's going to actually reflect away from the focal point this time. Like so. Now, with light being spread out and the light rays not focusing on a point on this side of the mirror, how can we determine the focal point or the focal length of this mirror? If we give a predicted line, so where the light ray would go, if it were to travel straight through, we can determine the focal length. So this is going to travel straight through. We would then have using the same method as before, we can now establish that our focal point for this particular mirror is going to be at that point there. And our focal length is going to be at that point there. Now if we took our focal length, which is this length here, and we transferred it over to the other side, we would then know the focal length of our